All right, so our fourth page, we have Q is the midpoint of PT and RS. So let's write that down as our statement. Q is the midpoint of PT and RS. And our reason for that is the given. Now, what does that mean? Q is the midpoint of PT. So I know that's going to divide this into two congruent segments. Then Q is also the midpoint of RS. So it'll divide this one into two congruent segments. So I have some new information I need to put over here in my statement. The first thing that I need to write down is RQ is going to be congruent to SQ. Okay, why? Definition of midpoint. Okay, the next thing that I know is that PQ is going to be congruent to TQ. Why? Definition of midpoint. Okay, so now I've got two sets of congruent sides. Let's see what else that we can do. The next thing that I notice is that I have vertical angles right here and right here. Okay, so I can say angle PQR is congruent, PQR, to TQS. Okay, take a look at that. And why? Vertical angles. Okay, and now I've got two sets of congruent sides and one set of congruent angles. Notice the angle is in between the sides. This is side, angle, side. So now I can safely say that triangle PQR is indeed congruent to triangle TQS by side, angle, side. Okay, on this one we're given that AC bisects angle BAD and angle BCD. That is given. Okay, now let's go over here and figure out what that's going to do for us. So here's AC. It bisects angle BAD. When you bisect, you can make two congruent angles. And AC bisects BCD. So this angle is congruent to this angle. Okay, so we have some angles. Now let's see what else we've got. We need to write all this down. So angle BAC is going to be congruent to angle DAC. And then, let's go the other way, BCA is congruent to DCA. Now, what are the reasons for both of those? The definition of an angle bisector. All right, so everything's looking good. Now, AC, I can go ahead and say is congruent to itself. So AC is congruent to AC by the reflexive property. Now look at what we've got. We've got angle, side, angle. So now we can prove that triangle ABC is congruent to triangle ADC by angle, side, angle. Okay, and that is our proof for number 24. Okay, now let's look at number 25. We've got DE is congruent to FE. Now since this is different, I'm going to put it on a different line. Triangle HEG is equilateral. That means it's going to have 3 congruent sides and 3 congruent angles, but both of these were given. All right, so let's fill in what we know. DE is congruent to FE. DE is congruent to FE. And then it tells us that triangle HEG, which is in here in the middle, is equilateral. So I'm going to put 2 tick marks here. 1, 2, 3. Okay. All right, so now that we know that, the next thing that I'm going to say is that triangle DEF is isosceles because it has 2 congruent sides. And the reason is going to be the definition of an isosceles triangle, because the definition is that it has 2 congruent sides. Alright, so looking at this, since these two are isosceles, their base angles are also going to be congruent. So I know that EDF is congruent to EFD. Okay, so let's write that down. Angle EDF is congruent to angle EFD. Okay, why? Base angles of isosceles triangles are congruent. Okay, so we're making good progress now. All right, and so we can also say that EG, right here, EGD, this angle, is congruent to EHF, which is this angle right here. Okay, and let's write that down. Angle EGD is congruent to EHF. All angles of equilateral triangle are congruent. I'm going to cheat a little bit because I need some space. Okay? All right, and so now I can say we're trying to prove that DEG, which is this triangle right here, and FEH, which is this triangle right here, are congruent. And if you'll notice, you have angle, angle, side on those. Angle, angle, side, angle, angle, side. So we can now say that triangle DEG is congruent to triangle FEH by angle, angle, side.